Hi, my name is Xinyu Zhang, and I'm a PhD student at NYU Stern. Today, I'll talk about a joint work with Professor Divya Singhvi and Professor Samya Singhvi on a data-driven approach to improve artisans' productivity and distributed supply chains. So the artisanal industry plays an important role in global economy, and it's the second largest source of employment in the developing world, especially for women from the underprivileged class. Unfortunately, despite its vital role in global economy and social sustainability, artisanal industry is plagued by low productivity and the distributed nature of its supply chain, where millions of smallholder producers either operate independently or as part of a larger network dispersed across a large geographic area and mainly rely on traditional technique and manual labor for production. Our collaborator, Jaipur Rugs, works under this context. As one of the leading manufacturers of handmade rugs in India, about 60% of their looms have low productivity. Given this setting, we couldn't stop but ask, how can we increase the productivity in the distributed supply chain? To answer this question, we need to get on the ground. In fact, we've already made multiple field visits to the state of Rajasthan in India. Through interactions with different stakeholders in the supply chain, we learned that supervisors were recruited by Jaipur Rugs to make regular visits to the weavers, serve as a major node of communication between the company and artisans. Their interactions with weavers play a critical role in the supply chain. So immediately we have two questions. Does supervisor visit increase the productivity? And if the answer is yes, how can we leverage supervisor visits to increase the productivity? Before we can answer these questions, let's take a closer look at the data that we have. Our data come in two segments. We have the 5-year rug production data with detailed rug level features, and we have the daily supervisor visit records, which contains dates of supervisor visit to each loom. We also use the auxiliary data of distances and temperatures. This is a summary of some key variables that we have, and we're interested in the effect of visit frequency measured at the average days between supervisor visits on rug weaving times. Our base specification is a fixed effects model. On the left-hand side, we have the log of rug weaving times, and our key variable of interest is the average number of days between supervisor visits. We have an extensive set of controls, and we add fixed effects for loom, supervisor, harvesting season, and year to control for the idiosyncratic differences, seasonality, and trends. To tackle the identification challenges, we use the instrumental variable approach. The first instrumental variable that we have is the distance between the loom location and the supervisor's home location. We also consider a second Houseman type IV, which is the average days between supervisor visits for the previous rug assigned on the same loom. From the estimation results, we see a 3 to 14% increase in productivity from a 1-day decrease in average number of days between supervisor visits. Because our collaborator maintains a significant backlog of orders, this translates directly to a 15% increase in weavers' monthly income. Our analysis also suggests that the impact is heterogeneous, where rugs that are difficult to weave enjoy additional 27% relative impact from more frequent supervisor visits. So now that we established the positive impact of supervisor visits on artisans' productivity, how can we leverage these insights and schedule supervisor visits optimally? Suppose that we have two looms, and we know that one will be high in productivity and the other will be low in productivity. Then learning from our empirical analysis, we would want the supervisor to visit more on the loom of low productivity. Following this idea, we build a machine learning model to predict loom productivity and define the village level target visit, which schedules a higher number of visits for villages with loom predicted to have low productivity. Based on the prediction results, we construct an optimization problem that minimizes the difference between scheduled visits and the target visits, while ensuring that the supervisor takes towards satisfying the practical constraints. Thus, the predict and optimize framework generates feasible supervisor routes with extra visits on looms predicted to have low productivity. By drawing the connection between our optimization problem and the celebrated team orienteering problem, we show that there exists a polynomial time algorithm to solve the optimization problem with a good competitive ratio. To further assess the impact of our predict and optimize framework, we did extensive numerical analysis using real-world data. This figure illustrates the average weekly visits to villages with rugs of low productivity versus villages with looms of high productivity. In comparison with the baseline policy, which is currently employed by our collaborator, the predict and optimize policy increases weekly visits to low productivity rugs, while decreases weekly visits to high productivity rugs, thus indicating that the policy is capable of allocating supervisor visits to looms that have lower than expected productivity, who may benefit more from more frequent supervisor visits. Using the estimates from the empirical analysis, we can calculate its impact on weaving times, and our estimates suggest a 2 to 12% reduction in rugs with low productivity. So to quickly summarize, we did rigorous empirical analysis to examine the impact of supervisor visits on artisans' productivity, and we propose a predict and optimized framework to guide supervisor visits and improve artisans' productivity. We're currently doing field experiment with our collaborator. It is noteworthy to mention that although this work is under the context of Jepper rugs, the predict and optimized framework that we propose can be easily generalized beyond the distributed artisanal supply chain. We're very excited about these results, and we hope that you'll take a closer look at our paper. Thank you for watching.